chemistry time. All right. So today we're going to be doing some bell work. Tylee specifically requested that we do some bell work. This was the spooky ambient music, which was royalty free. YouTube.com. Anyway, so Tylee specifically requested that we go over some. What? Where did the trash can go from? Tylee specifically requested that we go over some of these again. It'd be nice if we couldn't just see the back of me the entire time, but whatever. I guess I don't need to hold the candle anymore either. Okay, so we're going to go over some more of these, explaining a little bit as we go along. So the first question reads, calculate the frequency and energy of a light wave that has a wavelength of 4.559 times 10 to the negative 5th meters. So, white, good. Yes, this is all going very well so far. Oh, except now I've done it. There we go. Okay, now we're, okay, perfect. So, what should I do first?
Right down your big.
What is the equation?
C equals lambda times nu.
C equals lambda nu. And so basically, Todd, as an explanation, this equation relates for any electromagnetic wave, which are things like visible light, ultraviolet light, infrared, gamma rays, X-rays, microwaves, radio waves. That's all of them. For any of those kinds of light, or any kind of light, this relates the speed of light in a vacuum, which is constant, that means it's always the same, to the light's wavelength and its frequency. So basically, since the speed of light is constant, the greater the wavelength, the lower the frequency must be, and vice versa. Okay, so now we've got the equation written down. What's next? Manipulate. Tell me what to do.
Divide lambda.
Okay, so C over lambda. Wait a second, that's not going to work. We're trying to find lambda, so divide nu over, right? Yeah, we're trying to find lambda.
Oops, I did that wrong. It says calculate the frequency.
Oh, yeah, okay, you're right. I'm wrong. Just, yes, divide nu over. You were right, Jasmine. You were right, Aisha.
It's too long.
We're going to try it again.
Oh my god.
There.
Equals.
Equals frequency. Okay, what next?
You're going to write your given.
So tell me what to write.
Okay, wait, what is that B thing called? I'm just gonna call
This is called the Greek letter nu, right, which stands for
For frequency.
frequency. So what should I write?
So nu equals
Nu equals
3.00 times 10 to the 8th meters per second.
Okay.
Divided by 4.559 times 10 to the negative 5th meters.
Answer, Natalie?
Oh yeah, 6.58 times 10 to the 12.
Done?
Yes.
For that
Right
part,
here.
With that part.
Right, because it asks also for the energy. So we found the frequency. Found the frequency. And now we need to find the energy. So I'm going to erase this real quick. You guys got all this, right?
Yeah.
And if you need to get it, you can pause it. Don't make fun of me, Natalie. Okay, anyway, now using the thing that we just found and coupled with the given that we already had, we can now write our new equation to find the energy, which is what, Hayes?
E equals H.
Logs.
H, right? A equals Planck's constant times nu. Manipulate?
No,
Nope. Why not?
because we're finding it.
Because we are, this equation is solving for E, and that's what we're trying to find as well. Tell me what to write next, Aisha.
6.626 times 10 to the negative 34th times 6.58 times 10 to the 12th.
This needs to move. Yeah, over there is fine. Right next to me. Hey, buddy. What? Times what?
Times 6.58 times 10 to the 12th hertz.
There we go. Okay. Equals energy, right? Answer? And what units should my answer be in, Hayes? Joules. And the answer is?
4.35 times 10 to the negative 1st.
Joules.
okay, so I have a question.
What's Let's see the question.
Instead of 10 to the 12th, I got 10 to the 9th.
On your
That's what I was
answer?
asking you. No.
Oh,
up there.
for your previous answer?
Right.
I would bet that you either had a positive 5 in this exponent, or you had some other typographical error. It's okay, none of that, like I said, it's just a typographical error. I would assume it's either a calculator error or a mathematical error. And neither one of those are, what we need to know about this for science is how the units relate to each other, how the equation is set up, and how to manipulate it. So as long as you can do that, and you put the appropriate numbers in, it's not going to make a huge difference to me whether the mathematics is correct. Other questions?
I only
Thank you.
got one number difference in mine.
Yeah, that's fine. Other questions? Okay. So this equation, in case you're wondering, is how we relate the energy of either a quantum or a photon to that particle or wave's frequency. We use something called Planck's constant, which is another constant. The end.